So last night we discussed Hadoop 1 architecture. There I told you there were some splits happened. I mean, there are some rules to make it happen. So what is that rule? Yesterday there was some chunk of data which I divided into two. Then I made replicas. Then I kept it in different data nodes. So there is a rule for it. So Doug Cutting, the founder of Hadoop, he has designed it. So by default, the block size will be 128. If something here, I have taken an example of 200 MB data size. Data size is 200 MB, but the block size minimum will be 128. If something is below that, then that is okay. If something is above that, then that is the minimum block maximum uh, data size of that block. I will show you that. So let me show you. Okay. Here you see the default Hadoop block size is 120 MB in modern versions. So for now, if you are not giving any rule, by default, it will, if you are giving 200 MB of data, then it by default, it will make two copies. First thing, it will divide it to two blocks. Let me show you that. Here there is 200 MB data. So what it will do, first 120, it will take it out. Then remaining whatever data is there, the size is there, it will keep it in another block. For example, if it's 256, then also it will be two blocks, 128 and 128. If it's exceeding 256, let's say 260 MB, then 128, 128, 256, then another block will be there, that is 4 MB. Clear? Understood this point? So then accordingly, this split will go, then this block is splitted, then it will go and rest in three different nodes. Three replicas by default is the rule. Hadoop rule, there will be three replicas and they cannot sit in a single data node. They have to sit in identical data nodes, different data nodes. Not in single data node they can sit. Three replicas will happen, three different data nodes will be allocated. Here I am showing you three. There might be 1,000 data nodes in single big data cluster, Hadoop cluster. So the FS image, I told you FS image is heart and soul of, let me write it here. Heart and soul of full Hadoop system. FS image. This particular file is heart and soul of Hadoop system. This file has all the data, which node is having which data, which block is sitting in which node, and which node is empty. I can allocate if it's empty, I can allocate one block size to it. Accordingly, it will decide. FSC message all the data. FSC message will tell that these are the data nodes which are filled. These are the data nodes which are empty. Accordingly, we can allocate the new blocks which are coming, data blocks which are coming. So FS images, heart and soul, as I told you, of Hadoop system, we will discuss about this file today. Our whole discussion will go on this file particularly. Uh, till now, what we have discussed, Hadoop 1 I have covered, and Hadoop 1 I told you, I just told you there is some data, we will split it and accordingly we will place it in different data nodes. But there is a rule to it. But you can change that rule. There is a config file in Hadoop system. There you can change. You can increase the block size according to your usage. If your data is very big, the blocks are coming big every single day. You are getting 10 GB file. Then you can increase that block. You can divide it to two block, 5 GB, 5 GB. You can give the maximum block size 5 GB. That can be configured, that is allowed to configure. But by default, if you are not doing anything, 128 is the maximum block size. Accordingly, it will divide. If you are having 1,000 blocks, 1,000 MB, or maybe 1024 MB, that is 1 GB. 1024 is 1 GB. Yes, I think 8 into 8, 128 into 8 will be 1024. Let me open calculator. 128 into 8, that will sum to 102. Yeah. So here it will, if there is 1 GB file, then there will be 8 blocks. 128, 8 blocks will be splitted. Then each block will have three copies, three replicas. Then understand 8 block first splitted 1 GB file. 8 blocks will be splitted with 128 MB each. Then each block will replica will happen 3 times, right? So 8 blocks into 3 times, it will be 24 blocks. And they cannot sit in a single node. I mean, every single three will go in a different node. I mean, if I will tell you, let's take that example. Let me clear properly. These concepts will be clear. Let's say here there is 1024 MB. Let's take it 1024. This has to be black. Let me get back. Okay, this block is 1024 MB. Ignore that alignment. Okay, this is 1024 MB. So what I told you, if it is 1024 MB, then Hadoop will do 8 splits of this particular block, 120 MB each. 8 splits it will do. Let me decrease the size. So if you will sum up, it will come 1024, 8 blocks. As I told you, each block will have 3 copies. That is the rule. Then this 8 will go to different. The first one will go to, let me delete these ones also. Delete. We will quickly skip to our next topic. We are running out of time. Okay, let me fill it first. Not this color. Okay, then the first one will have 3 copies and they will sit in 3 different nodes. They cannot sit in single node. So let me copy it properly. 3 copies of this first one. Let it be here, first copy. Then the second copy of that cannot sit in that data node. It will go to another data node. Then third copy of that particular block. This is the first block I'm talking about. Then this will go to the third one. They cannot sit in single data node. Is this clear? Accordingly, every single data block will go to different nodes. This 128 MB can come to this node. The next copy of it cannot come to this node. This has to go to another node. You understood? If I am dividing a file with 128 MB each, I am dividing that particular file and I am separating it with 120 MB each, then there will have different data and they cannot sit in a single data. So all these 3 copies can come and sit in this 1 2 3 node. There are 3 data nodes here. You can see there are 3 data nodes here. Here 3 data nodes. These 3 data nodes can have all those 8 blocks. The first one can have 8, the second one can have 8, the third one can have 8, but they will be identical. They are not those 120 MB file. That is why I have given that example 128 and 72. At that point of time, that was quite clear. 128 and 72. The first 128, 3 replicas gone to 3. This is not 124. This is 200 MB. Then this 72 will go and the first copy will sit and the second copy cannot sit here. Even there is space, it has to go to another. And the third one will come to the third place. They cannot share the same data node. They have to go to different data nodes and sit. Clear? This is clear, right? This part is clear. This is block split. This is called Hadoop block split. This is how those blocks are splitted, and there is a rule for it. 128 MB is the max size. Then accordingly it will divide. If there is 1 GB, then there will be 8 blocks. You can do that math. You can easily do that math. Clear? This part is clear. We'll skip to next part. If this part is clear, there is very important part which we'll be covering today. Can I get a yes from
Yes,
you all?
yes,
Okay.
yes.
Okay, all good. I will I can start with another paint. Okay. So I'll start with few known facts. I'll relate it to a different thing. I'll discuss that. So there are some known facts we all know. Told you yesterday that client is important for us. Every project client is important for us. For our topic, that is get to a laptop. That laptop is our client. Second known fact. Every laptop has RAM and hard disk. Let me write it so we can properly relate it. So first thing, client is important. Client is important. So we have to respond. Any request comes, we have to respond it faster. Make it bigger. Client is important. Any request comes from client, we have to respond faster. Any request comes from any request comes from client, we have to respond faster. Response should be faster.
Hey, sorry to interrupt.
Yeah,
What
yeah.
do you write actually? I can't see.
Uh, could you please repeat? I think your voice is not that clear.
Uh, I was asking, where do you write the things you told right now? No? So I can't see anything, whatever you're writing right now.
Is it? Is it for
Yes,
everyone?
yes, for me also. I'm just
Okay, okay.
yes,
Let me drop and come back. I think one screen I have shared.
yeah,
Let
I
me.
think that's it.
If I'll drop, I will lose my. I am making someone host. Let me make someone host. Kisan, are you on laptop or phone?
Yes, I'm there on laptop.
Okay, let me make you host. Once I am back, make me host.
Yes.
I'm making you host, change host. Okay, you are host now. I have to stop share. I think I can stop share and start again. Mm,
Yeah, that will be.
Okay, can you make me host again? I need not to join back. I can stop share and start again.
How to make you host?
You can see participants list. There you can see my name. Participants list on, I think,
Yes,
on
yes,
your bottom bar. Yeah.
yes,
Here
yes.
you can see my name. Click on the right three dots.
Okay.
There you will see an option that make
Hmm.
host.
Make host.
Yeah.
Got it.
Okay.
Yes, yes. Change host.
Do it. I can see it on my screen once you will do it. You've done it?
Yes, done, done. Can you
Okay.
please check once again?
It didn't show me anything as notification. Okay, fine. I'm stopping share. Okay, I am the host. Let me share again. Entire screen. Tell me now which screen you are seeing. Are you seeing my desktop? Are you on my desktop? Can you guys see my desktop?
Yes, yes,
Oh,
yes, yes.
okay. Hide floating control. Now I am opening paint. Can you see the paint?
Yes,
This one also, right?
yes, yes,
Yes. Okay,
yes. Now
okay,
the
okay.
understood.
All good. So client is important. Any request comes from client has to be responded faster. Has to be. I'll relate it to our topic today. Then next known fact is every laptop, every single laptop, every single laptop has a RAM and have a RAM and a hard disk. This is also a fact, right? Every single laptop have a RAM and analytics. Yeah. Okay. This is another known fact. And third one. I think I missed one point. No, this is the point. If any application you open, it will come to RAM to serve you. RAM to serve you. This is a fact. If you guys who are new to, I think I'm in IT or computers, those who are non-IT people, it might be, I mean, you might not have known it. I'll show you. Can you see the applications open in the bottom bar? I'm highlighting one by one.
Yes.
These all are right now in my RAM, not in my hard disk. But Excel is not open. Excel is inside my hard disk. Once I will open it, it will come to RAM to serve me. I am opening it. Now Excel opened. Now it is consuming RAM memory. I'll show you that. Let me go to my task manager. Now you can see these are the things which are opened in my PC, and those are consuming my CPU memory, my RAM memory. If I will close the Excel sheet, if I'll close it, you see Excel is gone. So any application which is sitting in your hard disk, if you open it, it will come to RAM to serve you faster. It will consume your CPU memory to serve you faster. If you want to read something, it has to. If you want to anything, if you want to see an image also, photo also, you have to open it. Then one photo viewer or any image viewer application you are having, that application will open that. Then that application will come to RAM to serve you. If you are playing a video, then you are playing a video in VLC player or Windows player. Then Windows player will open. It will come to RAM to serve you. Anything you want to read, see, access, it has to come to RAM. If it's in hard disk, you can see the data size. You cannot access it. If you want to access it, then if you want to write something, read something, you have to open it. At that point of time, it will come to RAM to serve you. This part is clear. I think IT people knows it. Non-IT people may or may not be knowing it. So this is a fact also. Any application, if you want to interact with, then you have to open it. Once you open it, it will come to RAM. It will consume your CPU memory. So let me draw a diagram. So it will be, I think this part is clear. Still, I will take couple of minutes to show you. So this is your computer. There are two sections of it. There are two sections of it. One side is your RAM, one side is your RAM, one side is your hard disk. Hard disk drive, HDD. Okay. Here in hard disks, a lot of applications are sitting. Whatever the applications, when you start your computer, a lot of applications are sitting idle. Google Chrome, Excel, Notepad, any application you can call, those are sitting idle in your hard disk drive. If you want to access it, you have to bring those apps, to RAM. Once you click on open, it will come to RAM to serve you. And that point of time, it is in RAM. And you can access it faster, very faster. You can use it, you can type anything. Let me open Excel. Till now, I cannot interact with Excel. Right now, I'm opening it. It opened. Now I can do anything. I can do anything. It will respond. The response will be very faster. Why I'm telling all this, I'll come to that topic. Let me close this. Not needed. Don't save. Okay. So that was the concept. And the fourth point is, if you open, okay, that will come here. And then one more thing. If you restart your laptop, if I restarted my laptop and I am using, here I am doing something in my Excel. Let me do that and show it to you. This is, you have already experienced. Now I am typing something. Suddenly my laptop restarted. Will I lose this data or not? I'm going to lose this data or not? Whatever I am doing right now, the data, if it restarted suddenly, anything happened,
Mm.
it restarted. This data is not saved. So I will lost it. This is gone. I will lose the data. This data is gone, lost. It is not saved in hard disk. So that was the concept. If something is running in RAM, if it's not saved, then you are going to lose the data. Now I'll relate it to one thing, which is, let me open one more window. This part is a little tricky. You understand how this is called metadata management. Metadata management. I will tell you what metadata management. Metadata management. This is all about your FSMS. FSMS is having your all metadata. All about FSMS. How to handle FSMS. How to critically handle FSMS. I told you FSMS is heart and soul of Hadoop system. So you have to handle it properly. You have to manage it properly. When I am telling you that FSMS, just tell me where do you want FSMS to be to serve the client faster? Let me do that. Okay, this is your gateway laptop. This is, for example, your name node. I will make it a little bigger. This is your name node. This is your secondary name node. These are your data nodes. All are connected to name node. Same diagram. I have made name node a little bigger this time, just because I have to do a lot of things. So this is our client. This is our gateway laptop client. Gateway laptop or client. Gateway laptop or client. Done. This is our name node. Let me properly write. This is our name node. Name node. This is secondary name node. We will see how carefully, how wisely duck cutting the founder of Hadoop, that guy, how wisely he has managed that FS image. I mean, that metadata management happened. So we will not lose any data any point of time, but the FS image should respond to the client very faster. If you are sending any request, the response should be faster. Gateway laptop you are using, you are communicating to gateway laptop. You are sending any request, any kind of request it may be. So everything, all the data is with FS image. Name node will take the data from FS image. It will respond you faster. So, if you want to you want the response to be very faster, it should reach client as fast as possible. Then what do you think? Where FSMS should be? Where it should be? As per these four things, where it should be? If correct, it has to be in RAM. It has to be in RAM. But there is again one thing. If it is in RAM and suddenly something, FSMS is having data, right? FSMS having every single logs, which data node what file is there, which data node is responding, which data node after 3 seconds didn't respond, which data node after 10 minutes didn't respond, which data node is full, which data node is empty. A lot of data. Which data node is having what kind of data. A lot of transaction data in big data world. You can think thousands, millions, billions of data getting, I mean, the transaction happening, and everything is getting stored in that particular file. So if it is in RAM, if it gets crashed or restarted, then the data, of course, the file has to be open and it should be in RAM to interact it faster. If it's RAM and it restarted, then the data is gone. It is not saved, right? And one more thing, if the file is so big, so big, IT people can relate to it. I think non-IT people can relate to it. If you are handling a very big file, and you are trying to save it, sometimes it doesn't respond. Have you with that kind of scenario? Have you ever been to that kind of scenario when you are trying to save a file, it didn't save, it suddenly hangs, your laptop restarts? That has happened. I have seen when I was in my college days, I was running 3 games, NFS, Counter Strike, and Project IGA. My laptop always gets hanged. It will shut down, then it will again restart. Just because it's a very big size games, and the logs it's generating, the cache files it's generating, my laptop couldn't handle. You might have seen in Excel also. If you are handling a lot of data in Excel, you are trying to close it, save it, sometimes it gets hanged. This is a real time scenario, practical, right? So for that reason, you cannot save FS image frequently to hard disk. So you see how the cutting has managed that. Let me show the architecture here. As I told you, every laptop has two parts. One is RAM, another is hard disk drive. This side is RAM, let this side be your hard disk drive. So you got this point, right? Let me show a diagram here. This is your FS image. This is your FS image. It is in RAM. RAM FS image. Of course, if you want to FS image has to give the response to client, it has to be in RAM and opened. IT people can easily relate. If you want to interact with any kind of Excel sheet or file, you see when you code it, once you run the code, it will open first, then it will read it. This is I think IT people can relate it, but non-IT people, if something you want to interact with any file, it has to open. Writing part is okay. If you want to read something, if you want to send something, it has to be open and it has to be in RAM itself. So this is RAM FS image. It is in FS RAM. I mean FS image, FS image is in RAM. Then there are two scenarios. Let one side we save it. If we don't save it, if we save it, if we try to save it, then what is that issue? As I told you, it's a large file. If you try to save it, the laptop might get crashed. If you want to save it, you cannot do it frequently. That big file, it might get crashed. Then if you don't save it, if it's crashed, you are going to lose it. This is fact, right? You guys can relate it. You guys can relate it, right? Now I'll tell you how the cutting has managed it properly. Okay, now I am keeping. Okay, FS image will be inside RAM also. Inside. Let me do it. Okay, this is your FS image. Come on. This is your FS image. Let me write it. This is your FS image and it's sitting both in hard disk and RAM. This is your FS image. Now I have to do. Okay, let me give everything black. Let me write it in white so you guys can see it prop. FS image. Okay, so once your cluster starts, for example, cluster is every time, anytime, 24 hour now clusters are running, the data is getting generated. Let me, if suddenly something has stopped, let me show you once it starts. Okay, here, let me show it here. Let it be your FS image. Once it starts, it want to serve client, right? Client is here it want to serve client. So it has to come to RAM, correct? FS image has to come to RAM. I have to make it a little bigger. Simple concept. Focus. This is your FS image. So once your cluster starts, it has to come to RAM to serve the client. Understandable till now? Now it come to RAM, it opened. That FS image file, that log file opened. So it can interact with your client. It can send response to your client. It is inside name node. Understandable? This is your name node. This is your name node, and FS image is sitting inside. But this name node has two parts. This name node has two sections. One is hard disk drive, one is RAM. You understand? Till now, all clear? Are you getting it, everyone? All good till now? Shall I proceed or anything which is all good? Okay,
Yes.
okay. So this is FS image. It is sitting inside files what the cluster started. It was sitting inside hard disk drive of name node. It will come to RAM to serve. Is we got to know that FS image, if it's in RAM, we cannot save it. Hard disk, the name node might get crashed, might restart. We cannot save it. But if it suddenly got crashed, we are going to lose it. As in RAM, nothing is saved. So see the way the connect is designed. So you will have another part here. I will tell the name of this part. Another part here. Okay. So Duckcutting introduced one more thing here. He named it as edit logs. This is this is your edit logs. I will tell you how the mechanism will work. This is your edit logs. Okay. So the cluster started. Some transactions happened. Some data transactions happened. Any kind of transactions happened inside the cluster. Here something got. Here something. Some logs got generated. This this red part. Focus on the red part. Now let me see how to do both colors is red. Now it will be no. This I will make it red. This I will make it red. Okay, let's see if it is working now. Fine. I will do it. So some transactions happened. Cluster started, some data transfers happened, some transactions happened. You just focus on that red part. That is the log for that transaction. Clear? And then again some transactions happened. Let me color it as pink. Then again some transactions happened. And 1 hour passed. While these transactions are happening, they are being written in both FS image in RAM and edit logs in RAM also. Let me bring simultaneously. These transactions are being written in both FS image in RAM and edit logs in RAM. Then 1 hour passed. Focus. 1 hour passed. Yeah, 1 hour. 1 hour passed. Any questions comes to your mind, you can directly ask me. Do not wait till I reach till the end. If any doubts you have, you can directly ask me. So there is another file, log file. which duck cutting introduced is edit logs, and whatever transactions happen in that particular time and cluster started in first 1 hour, these are the transactions happened, and both transactions are being written in both fs image in ram and edit logs in ram. Then after and simultaneously this particular edit log is being saved to hard disk also. Continuous save happens continuous. Any transactions coming to edit log, it is getting saved to your hard disk drive. I'll tell you if you have question like, if you are not saving fs image, how could you save edit logs? Edit logs file is temporary. It is for 1 hour. Only for 1 hour edit log will be there. Then I will tell you what happens. Now after 1 hour passed, this 1 hour passed, 1 hour passed, then what will happen? Then this secondary data node, this ssn is secondary data nodes will take the copy of this fs image in name node, and it will keep it in its hard disk. After 1 hour it is happening, 1 hour completed, everything is happening. Now it will take a copy from the fs image of name node, and it will take a copy of this edit log 2. It will take a copy of this edit logs 2, and it will do the merging. Concentrate, it will do the merging. Who will do the merging? Secondary name node. Secondary name node is not responding to any client, it has no load. And just focus, you'll understand. Then it will do the merging. In the starting, let it be there is no fs image inside hard disk drive. Just now the cluster started, the new cluster started, so you can understand properly. Else there will be a lot of questions. Let me make it black. So it will do the merging. Once it merged, what will happen? Once the merging happens, so this merging will happen with fs image. The edit logs will merge with fs image. Then it will be sent back to, it will be in that particular 1 hour, all these codes are getting triggered. These are background things. These are code stuffs. The cutting get design that code. So after 1 hour, all these things will happen. I will again reiterate, if you have are having any kind of doubt here. This is a kind of important topic. You might get question or might not get, but as a data engineer, you should know how it works. Then after simultaneously, the merging will happen, and this particular fs image will be sent back to your name node. Then name node will delete these edit logs. You understood what happened? It is a copy. Why have I moved it? This is a copy. You understood what happened? Then only I will go to the next thing. You understood what happened? Every 1 hour, after every 1 hour, fs image in ram, fs image in hard disk, fs image in secondary name node will be in sync. Understood? Any questions till now? I will go for this next hour. Till now, all good, clear?
Samir, just one thing.
Yeah.
In every 1 hour, this edit logs, it is getting appended in hard disk. Sorry, in your name node hard disk, right?
Name node hard disk, yeah, it is saving it. I'll tell you the purpose. It is saving it. Every
No, no, it is appending.
yeah. If see first second some transactions happen, in next minute some transactions happen, which is
Hmm.
appending, but it is
Yeah.
transferring the edit logs to secondary name node after 1 hour. After 1 hour, all this process will happen.
Okay. So after 1 hour, secondary. So are we keeping any record in secondary node? No, right?
See, the edit logs will go to secondary node, right? It will merge. Secondary name node will bring a copy from name node, hard disk name node. FS image,
Hmm.
then it will merge the edit logs which it got after 1 hour.
Okay, so merging is happening in the secondary
Secondary
nodes,
name
right?
node. Yeah,
Secondary,
correct.
and after that, again, it is coming to the name nodes.
Correct. But
So,
why? Yeah.
uh, so end of the day means everything will be saved in the name node, not in the secondary node.
A secondary name node is keeping the data. Okay, I'll tell you. Secondary name node is keeping the data. Merging happened after 1 hour. Then
Mhm.
secondary name node got the last recent logs of last 1 hour. It will merge with the previous FS image which it copied from name node FS image. Then
Mhm.
it will merge it. It will send back to FS image which is sitting inside hard disk and in name node. Clear? It's
Okay,
clear, or it is
okay.
confusing? Still confusing?
No, no,
Clear?
no, no, no. That is got means after is sending to the name node, that, still that one of the record is still is keeping in secondary name node, right?
Correct. It is there.
Uh,
It will send the copy. It will merge and send the copy back to uh, hard disk drive FSMS in name node. So it will be replaced. The recent edit logs will come to hard disk drive. Here,
okay.
every load is taking secondary name node. You understood? Who is
Mhm.
merging it? Which processor is working here? Secondary name node processor is working, right? It will merge it. It will send it back. Then it will reach to name node, right? If I am sending any data to your laptop, then whose RAM will be used? Yours or mine? Mine will be used, right? You will be
Right.
receiving.
Mhm.
That is what happened. The load is taking secondary name node. But I will tell you, this 1 hour happened, then I will tell you the next hour. You will, I think your next questions will be cleared. Let me do 1 hour passed. The second hour I'm starting. Everything happened after 1 hour, all these things. Then the second, after 1 hour, let it be the transaction. First transaction happened. Let this be the transaction of next hour. Whole next hour, this is the transaction in blue. Where it will be saved, it will be, no, it will come to RAM in name node. It will come to F edit log in name node. It will then will go to simple same time. It will be saved inside hard disk drive of name node. Then after 1 hour, it will after 1 hour. This is the transaction happened in next hour. Now what will happen? Now the things will start. Now what will happen? This edit log will be sent to secondary name node. Then the merging will happen. Then this particular FS image will go and replace whatever is sitting inside hard disk drive of name node. It will go and replace it. Then these edit logs will be deleted. These edit logs is temporary only for 1 hour. So after every single hour, they will all be in sync. Now any question? There is a corner case. I will come to that part. For example, any questions till now? I'll go to that corner case. Any questions till now? I'll wait for your questions. If there is no questions, I'll proceed.
Means right now we got to know that that edit that logs, edit logs, and that FIS image, that those has been synchronized with secondary name node and first name node, right? In RAM and hard drive.
Yeah, see, your RAM is not working anything. Here, your RAM is not working. Name node RAM is not working. Name node RAM is totally being used for the gateway laptop or client. Whose RAM is being used here? Here, we are sending only a small part of the transaction. There will be billions of millions of transactions, but even in big data industry, the RAM size is also big, but they don't want to give that load. The edit logs will be only for 1 hour. After 1 hour, it will be sent to secondary name node. At that point of time, secondary name node will take a copy of whatever the FSM is sitting inside name node. Then it will merge that and send back to name node. So in every 1 hour, after every 1 hour, they will all be in sync.
That means it is kind of backup.
kind of backup. Yeah, kind of backup. It's kind of backup only. I'll tell you the corner case. What happens here? So after that 1 hour, some transactions happened. Let this be in red. So in the next hour, some transactions happened. So this transaction will be there in edit logs too. Edit logs in RAM, edit logs in hard disks. And for that corner case I'm coming. Now the 1 hour is not yet completed. It's not finished. It is ongoing. Suddenly this part restarted. This part suddenly your name node restarted. What will happen? This data is gone, right? This side data. You got my point? If it restarted anything in RAM, those are not saved. Correct? Anything in RAM, if you're writing something in RAM, if your system gets restarted, then RAM data is gone, right? Flushed out, removed, deleted. Correct? Am I correct here? You
Yes.
understand? Okay. This data is gone. I'm coming to the corner case. This data is gone, and that point of time, even secondary name node is not having this particular that transaction, read transaction. This transaction is not with secondary name node. This one is not with secondary name node. Just because 1 hour hasn't been completed. At that point of time, this side is gone. This part is gone. RAM is gone. This part is gone. Now restart happened. Name node restarted. What will happen? You understand the transactions? This transaction is gone. There is no. This is the recent transaction, right? Till read. This part is gone. Once name node restarts, what will happen? These two edit logs and FSMS both will come to RAM, and then merging will happen. This is not there anymore. Let me start. Okay, there is nothing else. Let me keep it outside so you'll see the sync. Now there is nothing in RAM. It's gone. Restart happened. There is nothing in RAM. Am I correct here? Now what will happen? Once restart happened, this FS image will come to RAM. I mean that log file will open up. This edit log will also open up. That file will also open. Then while what this name node will do, name node will take this edit log and do the merging. Anything operation you want to do copy paste, you have to open that file, right? Then only you can read it. So it will come to RAM. Then the first thing name node will do, if the restart happens, it will see what is there in the edit logs. Then it will merge it first. Those are the recent data logs, recent logs. Correct? Correct till now? Can you see these two are still in sync? The data which we lost. This is a copy. Why I have moved it? This is a copy. This edit log will be merged once it restarted. Then you see this part. This is they are still in sync. They look alike, right? After restart happens also. We haven't lost any data, any logs. Clear? Understandable? Any questions? I'll wait. Any questions? Any doubts? You can ask. I'll tell you what next. What will happen next.
Means that after that restart, RAM will keep that all that logs.
No, RAM, something is opened in RAM. If I have opened an Excel sheet in my RAM and working and sudden restart happens, then that data I will lose it. That data will not be there. I haven't saved it, right? Once you save it, it will go to hard disk.
Yes,
If
yes.
I'm correct, right? That data is gone. That RAM data is gone. This data is not there anymore. I
Right, right.
think you got my point, right?
Yes, yes. Yes.
Okay. So they both will come to. Okay, I'm moving it, but I shouldn't move anything. So what will happen once restart happens? Once restart happens, this FS image which is sitting inside hard disk will come, the edit log which is sitting inside hard disk, both file will open, then the merging will happen, and again the same process will start. 1 hour completed, this thing will go there, again the and that point, if once restart happens, it will delete. Once restart happens, I'll tell you what happens in secondary name node that point of time. Once restart happens, 1 hour completed, 1 hour completed, secondary name node will delete this. Secondary name node will again bring that part, will do the merging, and we will replace the FS image which is sitting inside hard disk drive. After 1 hour, even it got restarted, we didn't lose any data. Any data. Clear? Everything still in sync. If you have questions, you can ask me. I'll again explain it.
Yes, Sami. Just
Yeah,
one thing. As the data is keep on increasing, right? So
correct.
once suppose the data that had this size is 1 TB. Once it will reach to that threshold, then how it will the same time how it will manage that?
Okay, see, in big data world, we understand as a data engineer, we understand what is the data we are going to handle, what is the data getting generated every day. Accordingly, we will tell the admin people this is the data getting generated, and they will take the decision the cluster size. You don't think in usual if you'll enter in data world, you will see RAM size will be in TB, hard disk size will be TB, this small log file, the log file is getting bigger, millions of
Yeah.
data. A
Hmm.
small log file, it will be in the JSON file or XML file or normal notepad. Ignore. Take an example. That file is increasing, but that file is only having logs. That file will not reach GB data, but that file is getting bigger. You understand? If I am writing something in a text, in a Word file, Microsoft Word, I can fill 1,000 pages. How much data it will carry? 100 MB, 50 MB, 200 MB. But there is a chance that word can crash. That particular application can crash just because I have given a lot of data as per that application. Log files are simple files
Hmm.
inside a hard disk. Readable files, those are keeping logs. Clear?
Hmm. 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 Got it. Got it.
Any question? This is the architecture, how metadata management happens inside Hadoop. I was expecting one more question, but still I'm waiting if that question is with someone else. What if this whole thing is gone? Okay, it is in sync. Let me go back to that place. After 1 hour, what has happened? Okay, this looks good. All good. At this point of time, 1 hour hasn't been completed, and this whole thing is gone. This whole thing is gone. Computer can crash, right? It has a life. Corner case, extremely rare case. But this can go, right? We'll lose everything, right? Can secondary name node do secondary name node have? Does it have those edit logs? The red part is missing, right? Those recent logs of last hour logs. If we will lose this particular computer is self crashed. There is no scene of getting restarted. It has a life ended, crashed for some reasons. For some reason, it got crashed. We talked about restart. If this computer itself crashes, then do we have that red part, that red logs? This will be in millions also, thousands, millions. That 1 hour logs, which would have generated in last not last 1 hour, before completion of 1 hour. If 1 hour completed, it will go to reach to a secondary name node, and all this process will start. If it hasn't reached, if it hasn't reached 1 hour, and we lose this computer itself, name node itself, then what will happen? We lose this data, right? This is why in Hadoop, the cutting told In Hadoop 1.0, if name node is gone, there is no secondary name node which is going to come to rescue. But in Hadoop 2.0, we fix that. Shall I again reiterate it from the start? Okay, let me do it. Is this is okay? What will happen? Duck cutting introduced edit logs. There is another file similar to fs image, but that file is temporary. For 1 hour, it will keep the data, it will keep the logs, then it will transfer it to secondary name node, and then okay, then control C, control Y. Okay, okay, I have to do it. So 1 hour passed. First 1 hour passed. Then what will happen? This edit logs will reach secondary name node. In that particular 1 hour, secondary name node will take a copy. Let it, the cluster has just started. There is nothing inside this hard disk drive. Just restarted, it was empty. FS image was totally empty. It went to RAM. It the log file opened. Then the FS image file opened. It went to RAM. Then some transactions happened. 1 hour completed. Secondary name node will take the first copy. Take the first copy of the FS image, then it will do the merge, whatever is sitting inside. I mean, the edit logs which will reach to secondary name node after 1 hour. Then it will send back that copy and that will be replaced with the FS image which is sitting in name node. Then these edit logs will be cleaned up. These both will be deleted. Then next 1 hour, let me show the transaction in orange. Next 1 hour, the transaction is in orange. And this will be recorded in FS image which is sitting in RAM, edit log which is sitting in RAM, edit log which is sitting inside hard disk drive, it will save. Then edit log which is there after 1 hour completed. This particular data will reach secondary name node. Secondary name node will bring a copy of the last FS image which it has sent before a 1 hour. Then it will do the merge. Then name node will delete both edit logs in hard disk drive, also in RAM. Understood? Then it will send back. It will, in every single hour, it will send back and it will replace the FS image which is sitting inside your, it will replace it. Let me delete, let me copy it, let me paste it. So every hour, FS image which is in RAM, FS image which is in hard disk drive of name node will be in sync with secondary name node. There are two corner cases. If system restarts, there was a solution to it. If system restarts, then the FS image which is sitting inside hard disk, the okay, let me show you that corner case too first. So it will be clear. Let these transactions happen in last hour, and the hour is still not yet over. It's still going. Let it be 50 minutes, 45 minutes. This is the transaction recorded in all these three places. FS image in RAM, edit log in RAM, edit log in hard disk drive. And this point of time, RAM gets crashed. This particular restart, I mean, not crashed, system restarts for some reason. At that point of time, we will lose this RAM part. There will be nothing here. Everything is gone. We do not have this part, as this part is not saved. But what is saved? This side is saved. Once it's gone, then restart happens. We will lose this data. Come on. Okay. We will lose this data. There will be nothing in RAM, right? If restart happens, the data which is not saved is gone. Then FS image will open, that file will open. Once it open, it will come to RAM. Then edit log will also open. Once it opens, it will come to RAM. Then name node will first do the merging. It will do the merging, then as usual process start, then transaction starts, then new transactions will come, let it be. After the restart, this is the transaction. After restart happened, this is the transaction. After restart happened, this is the transaction. And this transaction will be recorded where in also in edit logs. It will be also saved in hard disk edit logs. Then this particular data, up 1 hour passed, this particular data will be transferred to secondary name node. What secondary name node will do? The merge will happen first. The merge will happen, then this particular part will be copied and it will replace whatever sitting inside your let me do it properly. Okay, this part
Uh,
is gone. Yeah, ask questions.
hey, Samir, just one thing. See,
Yeah,
data means all data is in form of logs.
logs. Yes, exactly logs. Kind
Okay.
of code. Kind of code. You can understand something is there is you see FS image is also tracking the heartbeats every 3 seconds. Is the data node responding? There will be 1,000 data nodes.
Hmm.
You understand every 3 seconds, 1,000 data nodes will be sending that they are alive. A Java code will trigger, they will respond. Response may be success, maybe 400. Okay. I mean,
Hmm.
what do you call it in API? Any
A
IT
bad,
expert
bad,
here?
a
Yeah,
bad, bad.
yeah. That request response will come.
Hmm.
Any Java code you will hit, any API request you will hit. But those
Hmm.
logs will be created continuously, and FS image is having that data, and that is proper.
Okay.
Yeah, you understood that part, right?
Okay. But this when we talks about the Hadoop,
Yeah,
means all the data, everything we deal with only in the forms of log.
yeah. Logs are
Is it, no, is it, I'm asking the right question, or I'm also a bit confused on it.
okay. Okay, let me show you what is FS image. FS image in Hadoop cluster. Let's read it. FS image file system image is a serialized snapshot of the entire HDFS namespace, directory structure, live permissions, block mapping stored on name node local disk. It represents a point in time state of the file system. Every single thing what is happening in Hadoop system, it will be carrying. I'm not going deep inside, but it is a kind of file which will have all the data. If I am having, for example, here I can see it. Here I can see it, but there will be codes. Here I can see my this drive is having 255, but I can shoot a code to know what is the my disk drive space and what is remaining. But that transactions happening, that is getting updated. There are proper codes. For example, see if this data node is for now this data node is having 2 GB space, but after 1 hour that particular data node will have 1 GB space remaining. Then it will replace that part or it will keep that log, or it will be I mean FS image will see that recent logs, how much space is remaining with this data node, so I can send more data to it. I can that will be proper coding happen. He's a very big person, big scientist, Hadoop owner. So he has designed it. I can tell you that this FS image is containing all the details of Hadoop system, every single details, which data node, space is how much remaining, what blocks are there sitting, which blocks, which data node is dead, which data node responded properly after 3 seconds, which data node is not responding. Everything is getting recorded. There is a proper code to it.
ठीक है ओके ओके सर
Okay. You
ओके
can, you can go through this whole
हम्म
article. There will be a lot deeper
हम्म
things into it, but this is the whole part. If you will
yeah.
try to understand, this is what he has designed it.
No, till now, what my means understanding was that big data means we talk about the backend thing. That's what I was thinking
No,
till
no,
now.
it is not big data. It is just
Oh.
a file which you will see. For example, I will go to that again fruit seller thing.
Mhm.
You are having crores of crores value fruit, but you are keeping a data in a note, right? Apple, I have
Uh-huh.
2 quintals.
Mhm.
Then 1 kgs I have sold. Then 199 kgs remaining. So you are keeping it
Mhm.
in a file, so you can see it. You are not going to go and count it. You are not going to weigh whole
Right,
one
right,
quintal apple. So this is
right,
kind of
right, right.
file which gives all those data. This is
Mhm.
not a part of big data. Big data is your store, but you are keeping it in a file. Every single details you are keeping inside a file. That file is your FS image.
Right, right.
If you
Okay,
want to
thanks.
know, yeah, if you want to know
Mhm.
anything about that cluster, you can know it from FS image.
Right, right. Thank you, thank you, thank you.
Okay. Any questions from this architecture? Any questions from this particular metadata management part? There might questions come, there might not. I'm not stressing much, but I want you guys to understand what is happening there. Clear this part how they all are in sync. But one thing I told you why Hadoop 2.0 came in picture. If this whole part is crashed, then the last logs it crashed in 50 minutes. There will be another 10 minutes for those logs to reach secondary name node. Secondary name node will not have those last 50 minutes logs. If the whole system crashed, that was an issue from 2006 to 2012, whole 6 years. There was continue name node failure issues were coming, and those edit logs were not reaching secondary name node. And that's when in 2012 Hadoop 2.0 came. I will talk about that in next class. We are already there. I don't want to start another new topic where you will be in the mid of something and then we have to leave. This part, all good. Any questions you can ask? We have another 20 minutes, I think. I think the math starts at 7, right? 7 or 7:30. You guys left? Or you guys already started watching?
No,
Okay, any questions? We have already time, else we will wrap up. I don't want to start a new topic today. The only issue in Hadoop 1.2 was name node failure. If name node fails, the whole system crash. Then those last edit logs, that those will be in millions. Those edit logs will not be there with the cluster. So Hadoop 2.0 came in picture in 2012. We'll start that in next class. I don't want to, starting a new topic for just 15 minutes, 20 minutes left, but that will take 1 hour, 1.5 hour, I think. If I could, then we'll wrap up. I will send this image. I will properly do it and I'll send this image to you.